The importance of randomness. Sample surveys. We'd like to know about an entire population of individuals, but examining all of them is usually impractical, if not impossible, so we settle for examining a smaller group of individuals, a sample selected from the population. You do this every day. For example, suppose you wonder how the vegetable soup you're cooking for dinner tonight is going to go over with your family. To decide whether it meets your standards, you only need to try a small amount. You might taste just a spoonful or two. You certainly don't need to consume the whole pot. Then you wouldn't have any left for your family. You trust that the taste will represent the flavor of the entire pot. The idea behind your tasting is that a small sample, if selected properly, can represent the entire population. It's hard to go a day without hearing about the latest opinion poll. These polls are examples of sample surveys designed to ask questions of a small group of people in hope of learning something about the entire population. Most likely you've never been selected to be part of one of these national opinion polls. That's true of most people. So how can the pollsters claim that a sample is representative of the entire population? The answer is that professional pollsters work quite hard to ensure that the sample that they take, represents the population. If not, the sample can give misleading information about the population. Bias. Selecting a sample to represent the population fairly is more difficult than it sounds. Polls or surveys often fail because they use a sampling method that tends to over or underrepresent parts of the population. The method may overlook subgroups that are harder to find, such as the homeless or those without phones, or favor others, such as internet users who like to respond to online surveys. Sampling methods that, by their nature, tend to under or overemphasize some characteristics of the population are said to be biased. Bias is the bane of sampling, the one thing above all to avoid. Conclusions based on samples drawn with biased methods are inherently flawed. There's usually no way to fix bias after the sample is drawn, and no way to salvage useful information from it. So the answer is, we randomize. So let's think about that soup again. Suppose you add some salt to the pot. If you sample it from the top before stirring, what will happen? With the salt sitting on top, you'll get the misleading idea that the entire pot is salty. If you sample from the bottom, you'll get the equally misleading idea that the entire pot is bland. By stirring, you randomize the amount of salt throughout the pot, making sure each taste is more typical in terms of the amount of salt in the whole pot. Randomization can protect you against factors that you know are in the data, like the salt. It can also help protect you against factors that you're not even aware of. Suppose, while you're not looking, a friend added a handful of peas to the soup. They are down at the bottom of the pot mixing with the other vegetables. If you don't randomize the soup by stirring, your test spoonful at the top won't have any peas. By stirring in the salt, you also randomize the peas throughout the entire pot, making sure that your sample tastes more typical of the overall pot, even though you didn't even know the peas were there. So randomizing protects us by giving us a representative sample even over effects we weren't aware of, like the peas. So how would we stir people in our survey? Well, we try to select them at random, and there's many ways to do that. Randomizing protects us from the influences of all the features of our population, even ones we may not have thought about. It does that by making sure that, on average, the sample looks like the rest of the population. Many of the sampling methods that we learned a little bit about in the first class that we'll learn more about in the second class show this. So not only does randomizing protect us from bias, it also makes it possible for us to draw inferences about the population when we only see a sample. Such influences, like these, are among the most powerful things we can do with statistics, and we'll spend much of the year discussing them. Keep in mind, though, that it's all made possible because we deliberately chose things randomly.